Here we go. So this one's just nice. Y prime is 2x plus 4. And when x is negative 5, they use the derivative. The derivative when x equals negative 5 is 2 times negative 5 plus 4. So that's negative 10 plus 4. That's negative 6. Check. Alright, we do it again. So y prime is negative 3x squared plus 8x. So when x is negative 4, the derivative when x is 4, sorry, just regular 4, is negative 3 times 4 squared plus 8 times 4. So that's 16. Negative 48 plus 32 is negative 16. Check. We do it again. So now we've got a quotient, so we're going to need quotient rule. So y prime is going to be the derivative of the top, which is just 0, times the bottom, which doesn't matter, and then minus the top times the derivative of the bottom. Square the bottom and off we go. And so the derivative when x equals 3 is just going to be negative 40 times 3 over 9 plus 5 squared. So that's negative 120 over 14 squared, which is something. It'll tell us down there. Okay. Let's see. So again, quotient rule. So the derivative of the top is 0 times the bottom doesn't matter, minus the top times the derivative of the bottom, all over the bottom squared. And so that'll be negative 2 over 6 squared when x is 5. So that's negative 2 over 36, which is negative 1 over 18. Excellent. Just a little bit of chain rule here. So bring the 1/2 down, keep the inside the same, and drop the power down by 1, and then multiply by the derivative of the inside. So then your derivative when x is 0 is going to be 1/2 times 4 to the negative 1/2 times negative 1. So that'll just be negative 1/2 for this and this. And then that's 1 over the square root of 4. So negative 1/2 times 1 over 2 is negative 1/4. Check. Okay. So let's see. So we have y prime is 1/2 times negative 3x plus 9. Subtract 1 from the power, so negative 1/2. Chain rule times the derivative of the inside. And so the derivative when x is negative 5 is 1/2 times 15 plus 9 to the negative 1/2 times negative 3. So that'll be negative 3/2 times 24 to the negative 1/2, which is unfortunately negative 3 over 2 root 24, which is negative 3 over root 24 is 2 root 6. So this is negative 3 over 4 root 6. So if I rationalize, negative 3 root 6 over 4 times 6 is 24. So negative root 6 over 8 when you simplify that. Let's see if that worked. Yay, we match. Excellent. Okay, we keep going. So now more chain rule. So the derivative of the outside function e to the anything, the derivative of e to anything is just e to that, and we'll write it again, and then times the derivative of the inside, so times the derivative of the exponent times negative 1. So your derivative when x is 4 is e to the negative 4 plus 2 times negative 1, which is e to the negative 2. We'll take that. It's 1 over e squared if that's how they have it on the bottom. Alright. So the derivative in ln is just 1 over the inside. We keep the negative, just multiplying by a constant doesn't hurt us. We multiply by the derivative of the inside. The derivative of the inside of this is just a 1. So now we evaluate when x is 5. So we have negative 1 over 8, and that is all. Some more chain rule. We're not concerned about the 2, he's just a constant. He'll be multiplying by the derivative of sine 2x. So the derivative of sine is cosine. Leave the inside b, then multiply by the derivative of the inside. So when x is negative pi halves, we'll have the 2 times the 2 is 4. Cosine 2 times negative pi halves is negative pi. And the cosine of negative pi is negative 1. The x value at negative pi is negative 1, so we get negative 4. And again. So again, we're not concerned about the constant. The negative 1 will just be multiplying by the derivative of tangent. The derivative of tangent is secant squared. Leave the inside b, multiply by the derivative of the inside. Then when x is negative pi, we'll have negative secant squared of negative 2 pi times 2. So this will be negative 2, this will be 1 over the cosine of 2 pi squared. So the cosine of 2 pi, the x value at 2 pi is 1. So this is 1 over 1 squared, so that's just 1. So the final value, negative 2 times 1, negative 2. Cool. And, oh, sweet, we did it. So let's check them. So we got negative 6. Looking pretty good. Excellent.